Hello everyone, in this video I'm going to show you how to do a linear regression in Python. So it's going to be a very quick introductive tutorial on how to do it, and the data set that we're going to use is about store sales. So we're going to try to see what are a couple of drivers that drive store sales up, down, or actually are not important. If you're interested in overall statistics, econometrics, please do check out my Udemy courses. I also have one on machine learning, so don't forget to do it if you like this video. So let's get started, and the first thing that we need to do is to import the libraries, and we're going to leave this one as a comment, import libraries. And now what do we need to do? So there is just one library that we need to do, which is import stats models.api as sm. Next, now that we have imported it, we need to get the dataset, and the dataset is actually included inside our library. So as a comment, get dataset, and we're going to call it dataset and do equals. And now we go to our SM library that we have just imported. We're going to go to datasets, and then which is the module, and then we're going to get the function get and then underscore R dataset. Overall, R is actually far more abundant when it comes to datasets within the libraries, and there was someone, which I think it was a great idea, that created this function that retrieves the data sets from R. Now, what do we need to include? So if we do Control I and ask for help, there is a couple of things that we do need to include. So the data name, and for us, the data name is clothing, and then comma, and then we do package. So which R package is this data set included? And for us is the ECDAT. Here we go. And let's select everything, and to run we do F9. Here we go. And we see here that it will appear in our variable explorer. And if we go and if I actually click here, we see that there are several things: doc, data, cache, package, raw data. And in truth, we actually only need one thing, which is this data parameter. So in order to actually get the data set, because this is not, a data set per se, what we do is, so we do again data set, because that's the final name that we want. And then we go to our data set, because that's the name that we gave it previously. And again, if I go to it, so what I want is data, so I do dot data. Here we go, let's do F9 again. And here we go, we have our data set over here. And we have here actually a lot of variables. Fortunately, there is some documentation on all these variables, so let's take a look. And this is all the data. So we have T sales, annual sales, which is the sales per square meter. We have the margin, which is the gross profit margin, number of owners, number of full-timers, number of part-timers, number of helpers, hours, so number of hours worked, number of hours worked per worker, also investment in shop premises, investment in automation. We also have sales floor space and the year start of business. So I'm going to choose some of them. And the next step that we need to do is that to do a linear regression in Python, it is mandatory that you isolate the y and the x variable. Now, to isolate the y, so y equals, and I'm going to go again to my data set. And I would say that my problem here is that I want to maximize sales. So I would say that the most important driver that I have here, or the most important KPI that I would like to study, is this T sales. So how to do that? We go to our data set again. We use the function iloc, open square brackets. Now we start off with the observations, and we want all of them. So I put a colon, now comma, and now I want the first column. So, but in Python, the first column is actually with a 0, so index starts at 0. So I need to include a 0 here to include the first column. So here we go. Let's do F9. And here we see our total sales. Next step is to get the X, and in similar fashion, we go to our data set. And now I think I would rather name my variable. So I do lock, and then I do square brackets. Then I want all the observations again, now comma. And now I open again the square brackets. And now I open quotes to start naming them. And I've selected 3 for this, so margin. And why margin? Because the lower the margin, this means that the store is being more aggressive on discounts. And I think this is a very valid variable. So to really, attract more and more customers through lower price points. Again, and full, so number of full-time employees, I opted for this one. And I also chose start. So when as this company started selling. So when this was the first time that the store opened. And when it comes to start, the key idea is more, is there value to having a store for many years in which you'd have already your customers that have already been there for many years and are loyal to you? So is there value to this? So let's do F9. And here we go. We see our X with margin and full and then start. Now that we have done this, then we can actually do our linear regression as a comment. And here we go. So there is one thing that we need to go to our X, is that it is particular to this library, but we need to add a constant. And this constant will then be replaced by the intercept when we do the linear regression. It's of absolutely no value, but it is something that we must do. Next, to actually do the linear regression, we need to store the function somewhere. So we're going to call it model. So this is where all the information will be stored. And then we go to our SM function, and then we use OLS. So this is the function that we need to use in order to do a linear regression. Let's do Control I again to ask for help. And not a lot of documentation, but there are a couple of things here. So we have endog and exog for exogenous. So endogenous or endog is our dependent variable, which is our y. And then we have exogenous or exog, which is our independent variables, which is our x. Next, there is one last thing. So we want to fit. So this is the function that we need to add on top. And after this, we just need to have a look at one extra thing, so which is to do the summary. So after we run our model, then we go to it and then we ask for the summary. And let me run one by one just for you to see. So we have our x, and we can see if I go to my x that there is a constant of 1 that was added here. Then if I run the model part, you can see that our model here was created. And, there's a lot of things here, but the key idea, okay, there's a linear regression inside our model object that we have just created. And then finally, in order to get the coefficients, we do model.summary. And let's increase the size to have a look. So we have constant. So this is, the constant that we have created that is now replaced by the intercept. And then we have the margin, which is very statistically significant, but I was actually expecting it to have a negative coefficient because I expected that lower margin, which would mean a higher discounts, would attract more sales. Then we have number of full-time employees, which is very statistically significant, and this makes sense. So more employees or, bigger store, better service, again, goes with intuition. And then we have start, which is statistically significant with a p-value of 0.16. But I would highlight that this standard error is really, really high. And this most likely means that we ought to have very decent amounts of outliers maybe, or that actually our data set has a lot of variability. And since we don't have a lot of observations, this leads that we are not able to make a very accurate conclusion given all the variability, which results in a very high standard error. So this is it on how to do a linear regression in Python. I hope that you saw how easy it is. You need to get the data set, you need to isolate your I and your X variables, and then you do the linear regression. If you like this video, please do not forget to subscribe to the channel for other videos on statistics, econometrics, and as well machine learning. I'm very much looking forward to seeing you in another video. Until then, have fun.